Hi class, today we're going to continue our discussion with the three variable systems of equations. So we've looked at two variables, and remember I mentioned that we're going to, in this class, look at 2 by 2 systems, which is two variables, which is what we did last week, compared to two equations. This week we're going to be looking at three variables, three equations. So we're looking at a 3 by 3 system. Okay. And I call them 3 by 3 mostly because we're going to be dealing with matrices later on, but just not quite. All right, so let's look at some examples and some notes. So the solution to a system of equations with three variables is the ordered triplet x, comma y, comma z. And it has to satisfy all equations. So it's not sufficient that like x, comma y, comma z satisfies two of them. It has to satisfy all three. So three variable systems can only have one solution, no solution, or infinitely many solutions. And so it's very similar to a 2 by 2 system. We have those three options: no solution, one solution, infinitely many solutions. So we're going to be looking at how to solve 3 by 3 equations right now in this video. And in class, I think we're going to spend some time definitely looking at what a solution looks like and how to look at them graphically and what does that mean. So just as a reminder, one solution with three variables. So if I had a graph like this, it would be 3 lines that intersect at one point. So I would have one line here, I could have another line like this, and then my third line just also needs to be able to go through the same point. So let's do this color here. So something like this. So then my solution would be this point right here because all 3 lines go through that. No solution would mean that either they're all parallel to each other, or there's a solution between 2 but not the third one. So even if one of them is parallel to the other one, so in no solution, like this is my axis, I could have something like this where I have 2 lines that are parallel but one is not. But because I don't have one overall solution, that is no solution. Infinite solution, just like we had in that last case, this is where we have all 3 are indicative of the same line. So they're all multiples of each other. So let's take a look at how to solve some of these. So to solve a system with 3 variables, we want to eliminate a variable from a pair of equations, very similar to what we did then. Then eliminate the same variable from another pair of equations. And so basically, if we're going to eliminate x, we're going to take a pair, combine them, eliminate x. We're going to take a different pair, combine them, and eliminate x. And we're basically forming a 2 by 2 system by getting rid of a variable in the third one. And then we're going to solve the resulting system of equations from step 1. And we're going to use substitution to find the values of the third variable. All right, so we're basically reducing a 3 by 3 system into a 2 by 2 system. So take it slow, especially at the beginning. Definitely take it slow. There are a lot of steps to a 3 by 3 system. And this is one of the reasons why we don't go further than this, right? So to solve each of the systems here, let's look at this first one here. And I think let's go ahead and get rid of the variable z. And so I'm going to do z because notice here 2z, 3z. So if I just combine these two, then I know that I can get rid of that. So I'm going to call this combo A. So combo A is going to be that top equation, x plus 3y plus 2z equals negative 13. And then that bottom, 5x plus 2y minus 2z equals negative 11. So notice that when I combine both of these equations, I can see that I don't have to multiply anything by anything because if I just add down, both of these kind of cancel out. So I get negative 13 minus 11. That's going to give me a negative 24. And now I have 3y and 2y. That gives me 5y. And x and 5x, which gives me 6x. So this becomes one of my new equations. Okay, so I'm going to box that in. All right, now I need to figure out, all right, what other 2 equations am I going to combine to get my next step? So I take any 2 to combine and I'm going to get rid of z. So I'm just going to go ahead and combine the last 2. And we're going to call this b. I could have combined the last one and the first one. It doesn't really matter. You're going to get the same answer. Your process will look a little bit different, but you'll get the same answer. So for b, here I'm combining my b. And so I'm going to have 5x plus 2y minus 2z equals negative 11. Okay, I can barely fit it in here. And then I have 7x minus 4y minus z equals 29. All right, this bottom one, because remember, I got rid of z in that first one, I have to get rid of z again. So that bottom one, I need to multiply that bottom equation by 2. I'm actually going to multiply it by negative 2. So when I multiply by negative 2, that's going to be a positive 2, and then these kind of cancel out, okay? But let's go ahead and rewrite this equation. So I'm going to have 5x plus 2y minus 2z equals negative 11, and then that bottom one is going to become negative 14x. Negative 2 times negative 4, that gives me a negative 8y. Negative 2 times that gives me a positive 2z. And then negative 2 times 29, that's going to give me a negative 58. All right, so now we can see that these two cancel out and those are gone. So let's take a look at our new equation. Negative 11 minus 58, that's going to give me, whoops. That's going to give me a negative 69. And then 2y minus 8y, that's going to give me, oh, that was supposed to be a positive. Negative 2 times a negative, that's a positive. So this is going to give me positive 10y. And then 5 minus 14x, that gives me a negative 9x. And so this would be a positive. And so this is our new equation here. So notice both of those equations in blue are an x and a y equation. So now those become my next step. So I'm going to take this equation and this equation, and we're going to combine them together to go ahead and solve. So let's go ahead and combine them, and then we're going to go ahead and decide which variable we want to get rid of. So I'm going to have 6x plus 5y equals negative 24. And then I'm going to have negative 9x plus 10y equals negative 69. All right, so now I have a 2 by 2 system, and I decide what I want to go ahead and get rid of. So I can see that 5y is a multiple of 10y. So I'm going to go ahead and multiply that top equation by 2, but specifically I'm going to multiply by negative 2. So when I multiply by negative 2, I end up with negative 12x. Negative 2 plus 5y, that gives me negative 10y. And a negative times a negative is a positive, so I end up with a positive 48. Now, this bottom stays the same. Okay. Alright, so if we see here, the 10y's cancel out. And then I'm left with 48 minus 69. That's going to give me positive 21. And then I'm left with 12x, negative 12x minus 9x. And then that's going to give me a negative 21x. Oh, sorry, this is a negative because of that negative 69. So now I'm going to go ahead and divide both sides by negative 21. I'm going to end up with x equals 1. And that's my answer for x. All right, so now that I know what x is, I pick one of these two equations to solve for y. So I'm going to go ahead and pick the first one. So I'm going to have 6 times 1 plus 5y equals negative 24. So then 6 times 1 is 6. I'm going to subtract that from both sides. So I'm going to end up with 5y equals negative 30. And now I'm going to go ahead and divide both sides by y. So negative 30 divided by 5 gives me a negative 6. So here's my y value. All right, 2 variables down. Now I need to find that third variable, that z variable. So now I'm going to pick from one of the main equations, now that I know what y and x are. So let's go ahead and pick the first one. So I'm going to have 1 plus 3 times negative 6 plus 2z equals negative 13. So 3 times negative 6 is 18. So I have 1 plus negative 18 plus 2z equals negative 13. And so negative 18 and 1, that's negative 17. And so then I'm going to move the negative 17 over. And then we're going to go ahead and have 2z equals a negative 17 move over as a positive. So then 17 minus 13 gives me positive 4. I divide both sides by 2 and I get z equals 4. And then, sorry, z equals 2, not 4, because I divide by 2. So z equals 2. And so here we have our three variables. And so that point would be x, y, z. So remember that it's always in alphabetical order. And so our x value is 1, our y value is negative 6, and our z value is 2. And that's how we solve that 3 by 3 system. All right, let's take a look at the next one. So in the next one, let's go ahead and we're going to pick a variable to go ahead and get rid of. And let's get rid of the variable x. So I'm going to take the last two systems. And since this has a negative x and that has a 3, I'm going to call this a. But when I do the a calculation, I am essentially having to multiply that bottom equation by 3. So I'm going to end up with 3x minus 4y minus 5z equals negative 31. And then it's going to be 3 times negative x plus 7y plus 11z equals 27. So in the multiplication, this equation is going to turn into negative 3x plus 21y plus 33z equals 81. And that top equation stays the same. Oops, it's going to be a minus. Equals negative 31. So we can see that these cancel out. So then I have 21y minus 4y. That's going to give me a 17y. 33z minus 5z. That's going to give me a positive 28z. And then 81 minus 31. That's going to give me positive 50. So here we see that this is our new equation. All right, so because I have a negative here for the x, I'm going to go ahead and choose this last equation and this first equation, and we're going to call this my b movement. Okay, because I can take that last equation and multiply it by 4 and kind of do very similar work to what I just did now. So that top equation is going to be 4x minus y plus 9z equals negative 3. And then here I have negative x plus 7y plus 11z equals 27. Remember, I'm going to multiply that bottom one by 4. And so I'm left with 4x minus y plus 9z equals negative 3. And then did I copy that? Yeah. Okay, so then I'm going to have negative 4x plus 28y plus 44z is equal to 27 times 4, which is 108. So we're going to go ahead and do this. And so notice our 4's go away. 28y minus y, that ends up being a 27y. And then 44z plus 9z gives us a 53z. So notice how much these numbers are a lot larger. And 108 minus 3 gives us 105. Okay, so that's our second equation. And so now we're going to combine those two equations. All right, so here we have 17y plus 28z equals 50. And I have 27y plus 53z equals 105. So these are pretty large numbers. And so we still need to figure out a variable to get rid of. And so in getting rid of these variables, let's go ahead and get rid of variable y. So I have a 17 and a 27. And so that means their least common multiple is really 17 and 27. So that whatever that multiplies to, which I believe is 450, 59. So I need to take that top equation, I'm going to multiply by positive 27. I'm going to take that bottom equation, I'm going to multiply by negative 17. Okay, so this becomes 17 times 27 is going to become 459y. 27 times 28 is going to become 756z. And then 50 times 27 is going to equal 1,350. Okay. Now, the bottom one, I'm going to get negative 459y minus, since I have a negative, times a positive, it's going to be minus 17 times 53, which is 901z, equals, again, a negative times a positive, this is going to equal negative 1,785. Okay. So just like before, notice that our y's cancel out. 756z minus 901z, that's going to give us a negative value of negative 145z. And then 1350 minus 1785, again, we're going to end up with a negative 435. We're going to divide both sides by negative 145. We end up with z is equal to 3, which is a nice small number. All right, let's go ahead, and once we have our z value, we're going to go back to our 2 by 2 system. So what we have here in blue, pick one to plug it in. I'm just going to go ahead and pick this one here. So I'm going to have 17y plus 28 times 3 equals 50. 17y plus 28 times 3, we have 84 equals 50. We're going to subtract 84 from both sides. We get 17y is equal to negative 34. Divide 17 on both sides, and we end up with negative 2. So here's our second value. All right, and then last but not least, once we have our z and our y, we can pick one from the very top to select. I'm just going to go ahead and pick the first one. It's up to you. Remember, you can go ahead and design this however you want. You can have many different ways to go about this. And then at the end, we'll all get the same result as long as we don't make an accidental mistake. All right, so I just went ahead and plugged in the y and the z there. So I get 4x minus 2, that's a plus 2. And then 9 times 3, that gives us a 27. So 27 and 2 is 29 equals negative 3. I'm going to go ahead and move that 29 over, sorry. I get 4x is equal to negative 32. Divide by 4, so I get x is equal to negative 8. And so again, we're going to write that as x, y, z. So we have negative 8, comma, negative 2, comma, 3. Okay. All right, so there are 2 examples where we went through 2 by 2 systems. I'm going to go ahead and stop this video here because it's already 18 minutes. If you feel like that was enough, go ahead and try the knowledge check. If you still need some more practice, or try the next 2 on your own, I'm going to put those in a separate video so it doesn't seem like so much in one video.